All right, so our lesson is 8.1. Today we're working on function tables. Let's start with some definitions. You'll want to get these definitions down because there will be a question later on where you're having to use your definitions in order to complete the question. Okay, so a function is a relation that assigns exactly one output value to one input value. The function rule describes the relationship between the input and the output. And we can organize these in a function table. Okay, the independent variable is the input value. And we call it independent because it could be any number. Okay, and the dependent variable is the output value, and we call it dependent because it depends on what the input is, and it will change based on our independent variable. Okay, so for our examples, we're going to start completing some function tables. Example 1 is done for you in the book, so let's look at example 2. We'll need to fill that in, either on your handwritten notes or in your textbook. So we'll just sketch a quick table. Alright, so our instructions are to complete the function table. The relation is the output is 5 times the input. Well, it already gave us that. The output will have to be 5 times the input. So we have our independent variables here. If you want, you could draw arrows. Okay, so for each one, if we have 5 times the input of 8, what will our output be? Thank you, Sarah. 40. All right, well, what if our input is 10? Thank you. And what if we input the number 12? And now our function table is complete. Alright, so let's test one more of these out. Alright, on A. Alright, so after you work, you will plug in your input for X. So our output on the first one is 0. Plug in 7 for X. Output is 3. Plug in 10 for X. And 6. Alright, not too bad, right? Okay. Well, on the next page, on 581, we are going to find the input. They're going to give us the output, and we have to find the input. So, I want you to talk in your group about what strategy you think we're going to use if they give us the end and we have to find the beginning now. Take about 30 seconds. Go ahead.
Divide. You would do what I have. Oh, I got it. I'll tell you what I think. Whenever it says times 3, so you divide 6 by 3, and then that would be 2. That would be then 15 divided by 3, and then 21.
All right, raise your hand if you would like to share your strategy. Lily? Okay, for this particular case, why are you using division?
Well, you divide the output divided by x.
Divided by which one? Well, we don't know x. We're trying to find x. So we're dividing by
3.
and then we will know. So will we use division every single time?
No.
Okay, why, Paige?
Because if it's like a if it's a subtraction problem, then you have to use addition to figure out the answer, because it's just like the problems we've been doing. It's the x times 3 equals 6. So we're trying to find x.
Good. So it is like our equations where we were using the opposite operation to undo and work our way backwards. Very good. So here, if my output is 6 and I divide it by 3, what do I get? So the input would be 2. All right. And what about 15? If I divide it by 3.
5.
And 21 divided by 3.
7.
All right. So that'll give me the input. And then I can just go back in and I can plug in the 3 times 2, the 3 times 5, and the 3 times 7. And so I worked it backwards. Okay. Let's try that. I'll come right here. This will be problem C. This one has a little bit more of a challenge to it, doesn't it? We've got 2 different operations that we need to work on. Why don't you talk for a minute in your group about what strategy you're going to use to find out the input.
I think 3 times x plus 2. So 3 times x plus 2. You'd add 2 to the input, and then you'd times the input by 3.
Okay, raise your hand if you'd had a strategy that you used in order to find the input for each of these. Emma L., what was your strategy?
My strategy was first to figure out what the multiples were, and then I don't know if I'm saying this correct. What I did was try to figure out what it would do to do that. So I did 2 times 1, and then I did minus 1, and I realized that doing something like that would work.
Okay, so you sort of use trial and error, like you just tried a number for x to see. Okay, that's a strategy. Jay?
Could you do the output plus what you're subtracting and then multiply it by the variable number?
Okay, I think you might be on the right track. Let's try this. If we know the output equals 1, well, if our rule is 2x minus 1, that has to what? Equal 1, right? Okay, so what we'll do is we'll solve for x like when we were practicing our equations. Remember, we want to get x by itself. So watch this. Let's start with getting rid of this minus 1. So we add 1. All right, that will cancel. Are you watching? Here we go. It leaves us with 2x on this side equals a 2. Now I still need to get x by itself. What is the operation here?
Multiplication.
How do I undo multiplication? Okay. So we'll divide by 2. What I do to one side, I must? I have some gentlemen who are not focused. Then 2 divided by 2 equals 1. So that means my input here will need to be a 1. So 2 times 1 minus 1 should equal 1. Okay, well, let's try it with an output of 3. Let me move over here for some space. Okay, 2x minus 1 now needs to equal 3. Okay, back to the same thing. Let's get rid of the minus 1. How do we do that?
Divide.
Wait, it's subtract 1.
Subtract 1.
We'll add 1 to both sides to cancel that out. It'll leave us with 2x, and then 3 plus 1 is? Okay, now I need to undo this multiplication, so I will divide by 2, and I'll do that to the other side. That leaves me with x equals 4 divided by 2, which is, so this one, the input would have to be 2. So 2 times 2 minus 1 should equal 3. Does that check? Yeah. 2 times 2 is 4. 4 minus 1 is 3. All right. Now, we can sometimes start seeing a pattern so that we wouldn't have to work it for a third time. But let's work it. For the third one, 2x minus 1 now needs to equal 5. We'll undo subtract 1 by adding 1 to both sides. Leaves us with 2x equals 6. Undo your multiplication by dividing both sides by 2. So now x will need to equal 3. So this time, 2 times 3 minus 1 gives us 6 minus 1, which does equal 5. So now it's complete. Okay, I would like for you to try one of those on your own. So D, I'll give everybody a minute to catch up on that, while others are starting problem D on your own. Show of hands who still needs this table. Bless you. All right, for this table, we are working backwards again because we're given the output. All right, first one. 3x plus 2 needs to equal 17. That's a little bit blurry there. All right, let's start with getting rid of this plus 2. How will I do that?
Subtract by 2.
From both sides. Leaves us with 3x equals 15. Now I need to undo multiplication. How do we undo the multiplication? Divide both sides by 3. X should equal 5. Alright, and then when we plug it in, 3 times 5 is 15, plus 2 does give us 17. Okay, for the next one, 3x plus 2 now needs to equal 20. So we will subtract 2 from both sides. Leaves us with 3x equals 18. Divide both sides by 3 and x will, equals 6. Okay, and then for that last, let me plug it in. All right, and then for the last one, now 3x plus 2 will need to equal 29. So subtract 2 from both sides. Give us 27. And then we will divide both sides by 3. So this time x will equal 9. And they check. Jay?
Another thing you could do, since the last one, the second one that we did, is 20. The output is 20, and the third one is 29. You just went up 9 more times, so the input would be 9.
Oh,
Because you would multiply 3 times 9. And then
on example 4, this type of example, we're doing the same thing. They're giving us a scenario. We're filling in the table. But then the next step is they want us to graph that function table on the coordinate plane. So let's actually look at page 582 because the example on 581 is already completely done. And you can look back at that if you would like to on your own. So let's work the one on 582 together. All right, Brianna bikes 12 miles per hour. The function rule that represents this situation is 12x, where x is the number of hours. We're going to make the table to find out how many hours she has biked when she has gone 12 hours, 36 hours, and 12 miles, 36 miles, and 48 miles. And then we're going to graph it. So by telling us the number of miles, they have given us the output. All right, and since this is just a one-step equation, I don't have to do all the work I did like up here on the two-step equations. Just one step. So all I have to do is the opposite and work backwards. All right, so opposite of multiplication is?
Division.
All right, so 12 divided by 12 will give me?
1.
36 divided by 12 will give me?
3.
Okay. And 48 divided by 12?
4.
Okay. So then 12 times 1 is 12. 12 times 3 is 36. And 12 times 4 is 48. All right, so notice how it says the input is X. So then the output will be our Y. I don't really have room in there for that. Let's think back way deep in our memories to when we were graphing on a coordinate plane. When we graph, our ordered pairs look like this. X, comma, Y. So let's write all of our coordinates here. So for the first one, X is 1, Y is 12. Does everyone see? The second one, X is 3, Y is 36. And the third one, our X will be 4 and our Y is 48. So now it wants us to graph this, and if you're doing it in your book, it's already created for you. You can just plot your points there in your book. That'll save you some time. Okay, so our x-axis is horizontal, our y-axis is vertical, and I know my spaces aren't even imperfect, but we'll get the representation that we need. Alright, now remember, when we graph on a coordinate plane, we start with the x-axis. So you start at 0, and our first coordinate is 1. So we go to the 1, and then up to 12. And it's an approximation somewhere between the 10 and the 15. We'll go there. So this one is 1, 12. All right, the next one is 3 and 36. So start back at the 0, follow the x-axis to the 3, and then 36. Estimate. It will be somewhere between the 35 and the 40. And then finally, we have 4. So go back, 4 and 48. Go back to the 0. Follow the x-axis to the 4. And then we'll follow y up to the 48. Estimate between the 45 and 50. And it's graphed.